In this video, we will discuss the concept of complex numbers. By definition, the set of complex numbers denoted by this symbol here, C, is defined as follows. Any complex number can be a number in the form a plus jb, where a and b are elements of the set of all real numbers, and j squared is equal to -1. And so it follows that from this definition, if j squared is equal to -1, then the square root of -1 is equal to j, if you get the square root of both sides. Now, examples of complex numbers are z equals 2 minus j3, z equals 1/2 minus j 2/3, or z is equal to e plus j pi over 6. As long as the a and the b are both real numbers, then if you put that in form a plus jb, then what you have is a complex number. Okay. Now, for a given complex number, a plus jb, the real part of the complex number z, denoted by re of z, so that stands for real part of z, that's equal to a, and the imaginary part of the complex number z, denoted by im of z, is equal to b. That is why if we have, for instance, the complex number z equals 3 minus j5, the real part of z is 3, while the imaginary part of z is -5. -5 kasi this one should be 3 plus j -5. Kung lalagay natin siya sa tinatawag natin na standard form or rectangular form, okay, or Cartesian form, it should be of the form z equals a plus jb. So that's the standard rectangular form of the complex number. So lalabas that we have your imaginary part to be -5. Or if you have z equals e plus j pi over 6, then the real part of your complex number z is e. E is an irrational number rather, okay? And the imaginary part of z is pi over 6. So again, the real parts and the imaginary parts of your complex number are both real numbers. Now, an additional remark, if z is equal to a plus jb, okay, and b is equal to 0, then z is a real number, okay? Because if you have z equals a plus jb and then b goes to 0, so meaning the imaginary part is 0, then what is left is only a, which is a real number, and so the complex number is simply a real number. Kaya nga, we can always say that all real numbers are complex numbers having their imaginary parts equal to 0, or having b equal to 0. Also, if z is equal to a plus jb, then z is considered imaginary. So basically, that's a given. No? So that's obvious. No? If both real and imaginary parts are present, then you have an imaginary number. And if a is equal to 0, no? If z is equal to a plus jb and a is equal to 0, then z is pure imaginary. So dito naman, sa third case, z is equal to a plus jb, the real part is equal to 0, then it follows that z is equal to jb. Ang matitira lamang is yung imaginary part, and so you can say that your complex number is pure imaginary. Next remark, number 4, two complex numbers z1 equals a plus jb and z2 equals c plus jd are equal if and only if a is equal to c and b is equal to d. So again, ang sinasabi lang dito, the two complex numbers are equal if both their real parts and imaginary parts are equal. So, hindi pwedeng maging equal yung dalawang complex numbers if parehas lang parehas lang yung real parts nila or parehas lang yung imaginary parts nila. So, both real and imaginary parts of the complex numbers should be equal for you to be able to say that Z1 and Z2 are equal. And then another remark is the identity element for addition is 0 and identity element for multiplication is 1. So there also exists an identity element for the set of complex numbers. So 0 kasi, for addition, if you add two complex numbers and one complex number is 0, the sum will always be equal to the original complex number. So halimbawa, if you have 3 plus J2, and then if you add this to 0, okay, the answer is also 3 plus J2. But the 0 that we are talking about here is basically 0 plus J0. Okay? So when you add 3 plus J2 to 0 plus J0, the answer is still 3 plus J2. So kaya siya identity element for addition. Now, same thing for multiplication, meron din tayong identity element which is 1. So it means that when you have a complex number, halimbawa 3 plus J2, the number that you can multiply to 3 plus J2 such that the product is also 3 plus J2 is the number 1. Okay, so basically here, when you set this number, yung 1, into standard rectangular form or Cartesian form, 1 is basically 1 plus J0. Okay? So 3 plus J2 multiplied by 1 plus J0 is simply 3 plus J2. So again, there exists addition identity elements and multiplication identity elements for the set of complex numbers. Now, by definition, we know that J squared is equal to -1. Okay? And so, square root of -1 is equal to J. So, what if you have J raised to a certain power, okay, N, okay, which is an integer, that is greater than 1. Okay? So, alam natin si J raised to 1 is J. J squared is -1 by definition. Now, by properties of exponents, J cubed can be expressed as J times J squared. I-add lang yung exponents nila, so magiging J cubed na ulit yan. So, but J is equal to J and J squared is -1, therefore J cubed is equal to -J. Extending further, you have J to the fourth. J to the fourth is J squared times J squared. So that's -1 because J squared is -1 times another -1, so you have +1. Now, J to the fifth is J to the fourth times J, which is, so J to the fourth is 1, and then times J to the 1, so that's J, so you have J to the fifth equal to J. J to the sixth is J to the fourth times J squared, but J to the fourth is 1, and J squared is -1, so J to the sixth is -1. J to the seventh is J to the fourth times J cubed, but J to the fourth is 1, J cubed is -J, so you have product, J to the 7 is -J. J to the 8 is J to the 4 times J to the 4th, which is +1 times +1, which is equal to 1. So you see here that there is a pattern. No? So may pattern, lumalabas yung mga values, starting with J to the 1, J squared, J cubed, and J to the 4th. So the values are J, -1, -J, and 1. For J to the 5th, J to the 6th, J to the 7th, and J to the 8th, you also have J, -1, -J, and 1. And so, for J to the 9, 10, 11, and 12, we can predict that the values of this, simplified values of these powers of J will also be J, -1, -J, and 1. And as you can see, by properties of exponents, makikita natin na kapag in-express natin yung power as a product ng dalawang J, no, na magkaibang exponent, makikita natin that this part here is a multiple of 4. Multiple of 4. 2 times 4, 2 times 4, 2 times 4, 3 times 4. multiples of 4, and then meron kang hiwalay, yung sobra, okay, yun ay basically remainder when you divide your exponent by 4. So kasi diba, j to the 9, if you divide this by 4, it's 2, remainder 1. J to the 10, if you divide this by 4, it's 2, remainder 2. J to the 11, if you divide this by 4, you have 2, remainder 3. J to the 12 is divisible by 4, and so the remainder is none, okay, or 0. So basically, dahil ang ating cycle nauulit every 4, when you divide the exponent kay n by 4, and the remainder can either be 1, 2, 3, or none. Okay? So alin lang doon sa apat na case na yon. So in general, if n is a natural number and r is the remainder, it's the remainder when n is divided by 4, then j raised to n is equal to 1 if the remainder is 0, j if the remainder is 1, negative 1 if the remainder is 2, and negative j if the remainder is 3. So yan yung kailangan natin tatandaan, no? Yung remainder. When you divide the exponent n by 4, yung remainder niya either 0, 1, 2, or 3, yung magiging value ng j raised to n, it's either 1j, negative 1, or negative j lamang. So for example, if you want to simplify, 7j to the 27 plus 5j to the 13 minus j raised to 64 plus 7j minus 2, ang ibig lang sabihin yan, kailangan nating pababain yung exponents ng j. Okay? By using our previous discussion, okay, you first divide the exponents n by 4. Okay, so if you divide 27 by 4, actually the important thing here is the remainder. Okay? So yung mismong quotient hindi importante. So ang kailangan natin is the remainder. Again, it can be either 0, 1, 2, or 3 lamang. So sa 27, pag dinivide mo to by 4, the remainder is 3. Si 13, pag dinivide mo by 4, the remainder is 1. Si 64 is completely divisible by 4, so the remainder is 0. So kapag in-apply natin yung previous natin na generalization, since the remainder of j to the 27 is 3, pwede natin yung palitan ngayon, no, ng negative j. And then since yung remainder ng j to the j raised to 13, remainder ng 13 is 1 when you divide it by 4, pwede natin palitan si j raised to 13 by j. And then 64 is divisible by 4, the remainder is 0, so j raised to 64 is just equal to 1 plus 7j minus 2. So simplifying further, you will have negative j7 plus j5 minus 1 plus j7 minus 2. Pag sinabi mo j7 and 7j, it's actually the same thing. Yun nga lang, by definition, yung binigay nating definition, ang sinabi natin na standard form is a plus jb, nauuna yung j. So, isinusulat lang natin siya in that form. Kaya instead of writing it as 7j, pwede natin siyang isulat as j7. So, parehas lang yun. And then ito, negative j7, 5j I write as j5. So, since meron akong negative j7 and positive j7, when I add this, magka-cancel yan. So, I only have here j5, and then negative 1 minus 2, it's simply negative 3. Or, the simplified form is negative 3 plus j5. Inuna lang natin yung real part. Okay? Negative 3 and then the imaginary part. But still, negative pa rin yung 3, tapos positive pa rin yung j5. Again, it's just writing it in standard form. Okay? Next definition, if p is a real number and p is greater than 0, then the principal square root of negative p is equal to j square root of p. Remember, sabi natin, if you have the square root of a negative number, okay, then what you get is a complex number or an imaginary number. So, yun. Okay? Binabalikan lang natin yung diniscuss nyo sa algebra regarding complex numbers. So, the square root of a negative number is an imaginary number. Okay? That's why, if you have, for instance, the square root of negative 4, this is simply j2. Kasi this is j square root of positive 4. Yun yung base dito sa definition. So, magiging ganyan siya. And then, the square root of 4 is 2. So, this is j2. Or, if you have the square root of negative 81, this is j square root of positive 81. Or, that's j9. Or, if you have square root of negative 13, now, since 13 is not a perfect square, kagaya ng 4 and 81, pag sinimplify natin to, we just write this as j square root of positive 13. And that's it. No? Kasi wala naman tayo makukuhang exact value for the square root of 13. Okay? And so, kapag meron tayong mga radicals, no, square roots inside or negative radicands inside your square root, no, pwede natin siyang i-express as standard form. Another definition, if z is equal to a plus jb, then the complex conjugate of z, denoted by z bar, is a minus jb. So getting the complex conjugate of a complex number is simply changing the imaginary part of a complex number, changing the sign, okay, rather, of the imaginary part of a complex number. So for example, if z is equal to z is equal to 2 minus j3, then the complex conjugate of 2 minus j3 is equal to 2 plus j3. Or if you want to get the complex conjugate of the number 9, then it is simply 9. Hindi nagiging negative 9 kasi wala ka namang imaginary part eh. So ibig sabihin, real part lang siya talaga. So walang magbabagong sign. If you want to get the complex conjugate of negative j, so that's simply positive j. Or if you want to get the complex conjugate of j plus 1, then this is, no, not j minus 1, but negative j plus 1. Okay, kasi nga, yung imaginary part, yung mababago yung sign. If it's positive, it becomes negative. If it's negative, it becomes positive. Okay? Now, going to operations on complex numbers, so you have the typical addition, subtraction, multiplication, and division. Given z1 equal to a plus jb and z2 equal to c plus jd, the sum of z1 and z2 is simply combining the real parts, a plus c, and then the imaginary parts, b plus d. So, idadagdag lang natin, i-affix lang natin yung j, okay, doon sa ating imaginary part. Kapag naman subtraction, okay, then what we do is we just subtract both real parts and then also subtract both imaginary parts. So, para lang tayong nag-a-add or nag-subtract ng like terms, no, ng algebraic, no, expressions. No. Pwede nating pag-combine, parehas na real, parehas na imaginary. Pero hindi natin pwedeng pagsamahin yung isang real, isang imaginary, and vice versa. So, if you have z1 equal to 3 plus j2 and z2 equals 4 minus j3, let's find the sum. So, z1 plus z2 is equal to 3 plus j2 plus 4 minus j3. So, actually, pwede natin gawin dito. Tanggalin yung grouping symbol, just simply 3 plus j2 and then plus 4 minus j3. Tapos, combine natin yung real parts. So, that will be 3 plus 4, so you have 7, and then j2 minus j3 is negative 1, no? 2 minus 3 is negative 1, so this is negative j. Okay, so parang pwede nating tingnan yung ating J as parang variable. Although hindi naman siya talaga variable, pero parang ganun din siya lumalabas. No? When we are adding or when we are subtracting. Okay? Halimbawa, we want now to subtract okay, Z1 and Z2. So Z1 minus Z2 is equal to 3 plus J2 minus 4 minus J3. So what we can do here is we can actually remove again the grouping symbols, but this time, dahil minus yung symbol natin sa gitna, we distribute. So this is 3 plus J2 minus 4 plus J3. And then combine the real parts. 3 minus 4, that's negative 1. And then J2 plus J3 is positive J5. So that is your difference. Now, pwede nyo tingnan ngayon, what if, baliktarin natin, what if instead of Z1 plus Z2, Z2 plus C1 ang gagawin nyo, ano kaya ang magiging sum? Is it different from Z1 plus Z2? Or kung Z1 minus Z2 meron tayo, negative 1 plus J5, what if pagbaliktarin natin, we get the difference Z2 minus Z1, will we get the same value or will we get a different value? So, do that as your exercise. Now, for multiplication and division, okay, since your complex number is of a binomial form, multiplying two different complex numbers basically means that we can do FOIL method. Okay? So here, A plus JB times C plus JD is simply A times C plus A times JD plus C times JB plus JB times JD, which is AC plus JAD plus JCB plus J squared BD, because you have J times J. But since J squared is negative 1, pwede nating palitan ito ng negative 1 such that you'll have here AC plus, and then we can combine these two terms. You have JAD plus CD minus BD. So basically, the real part of your product is AC minus BD, and then the imaginary part, JAD plus CD. So you don't have to memorize this form. No? Ito lang yung general form ng product, pero you just have to do FOIL method whenever you are getting the product of two complex numbers and then simplify. And so that's it. Huwag lang kakalimutan na palitan si J squared ng negative 1. Okay? Kasi magiging kasama yun sa real part later on. Now, when we are dividing, we have to use or utilize the complex conjugate of the denominator. Kasi diba, as a rule, bawal ang square root, bawal ang radical sa denominator. Now, in this case, if you have a complex number in the denominator, it follows that there is a radical. Kasi nga, yung JD na yan, J is equal to square root of negative 1, diba? So basically, dito, you have a radical in the denominator. And so, to remove that, we have to rationalize. And rationalizing, we need to multiply the denominator by its complex conjugate. So, the complex conjugate of the denominator, C plus JD, is C minus JD, right? So, you multiply the denominator and the numerator by the complex conjugate. So, C minus JD, C minus JD. So, kapag nagawa natin yon, yung ating numerator, we just use FOIL again, no, to multiply. So, you have here A times C minus J times AD plus J times BC, and then minus J squared times BD all over C plus JD squared. When you have, no, not C plus JD squared. It's C plus JD, so times C minus JD by special product. So it's C squared minus JD squared. Okay? So product ng, recall, no, product ng A plus B times A minus B is A squared minus B squared. Okay? And so product of C plus JD and C minus JD is C squared minus quantity jd squared. So simplifying further, you'll have here AC minus, pag combine natin to, you have here plus jbc minus ad, and then replace j squared by negative 1, and since minus yung nandun, magiging plus bd all over c squared minus j squared d squared. Or you have here AC plus BD, so combine this and this one, plus JBC minus AD all over C squared plus D squared. Because negative 1, again, replace the negative 1, magiging plus C squared plus D squared. So this is the quotient. Again, you don't have to memorize this form. Ang kailangan nyong tandaan is kung paano siya ginagawa. Get the complex conjugate of the denominator, multiply numerator and denominator by that complex conjugate, and then simply multiply. Now, as you can see, the denominator will always be z times z bar. Okay? Yung denominator mo will always be a form such that you'll have z times z bar. And so, lagi, ang magiging itsura niyan ay halimbawa, yung nasa denominator mo is a plus jb, imumultiply mo siya ng conjugate niya, a minus jb. So, ang lalabas dyan lagi sa denominator ay a squared minus jb squared, which is a squared minus j squared b squared, or that is a squared plus b squared. So, basically, the denominator will always be of the form a squared plus b squared. Real part squared plus imaginary part squared. Kasi lagi mong minumultiply yung denominator by its own complex conjugate when we are dividing. So in general, the product of your complex number and its own conjugate is a real number of the form a squared plus b squared. So for example, given z1 equals 2 minus j3 and z2 equals 1 plus j5, you have here the, we want to get the product and the quotient or the ratio. So first, z1 times z2, so that's 2 minus j3 times 1 plus j5. So using FOIL method, you will have 2 plus j times 2 times 5 is 10, so that's plus j10, and then j3 times 1, negative j3 times 1 is negative j3, and then negative j3 times j5 is negative j squared times 15. Okay? So you have here 2 plus j10 minus j3. J squared is negative 1. So, pag pinalitan natin to ng negative 1, tas negative din yun, magiging plus 15. So, we can combine 2 and 15. So, that's 17 plus j. 10 minus 3 is 7. So, you have 17 plus j7 as your product. Now, for the quotient, z1 over z2, that will be 2 minus j3 over 1 plus j5. Multiply the numerator and the denominator by the complex conjugate of the denominator. Denominator tayo tumitingin ha. So, that's 1 minus j5. 1 minus j5. And then, for the numerator, multiply natin. 2 times 1 is 2. 2 times negative j5 is negative j10. Negative j3 times 1 is negative j3. Negative j3 times negative j5, so positive, j squared times 15. And then, for the denominator, it will be, again, a squared plus b squared. So, in this case, 1 squared plus 5 squared. No, kasi, again, product ng a plus jb and a minus jb is a squared plus b squared. So, in this case, 1 squared plus 5 squared ang nasa denominator. So, you have 2 minus j13 minus 15. Pag pinalitan natin yung j squared by negative 1, divided by 1 plus 25. So you have here 2 minus 15 is negative 13 minus j13 over 26. So to write this in standard form, separate into two fractions, you will have negative 13 over 26 minus j13 over 26, or simply negative 1/2 minus j 1/2. So this is your quotient. So again, you can try doing z2 over z1 and then z2 times z1 and then compare with our previous answer if they will be the same or different values.